Good afternoon, ladies and gentlemen. Welcome back. Here's another video by Mr. Chen for grade 9 math, MPM1D, 1D3. It's part 2, really 2A or 2B, I can't remember, connected with our investigation or recap of linear equations, linear relations, and their investigations. If you didn't get a chance to find the other video related to the first part, please look at the Google Classroom or look at the YouTube video channel that we have. Again, as you can see from my list that we posted on Monday, we've actually finished part 1. That's already done. And today we're actually going to be looking at part 2, graphing of lines, which is in the other accompanied video, parallel and perpendicular lines, and talking about the third and final point called points of intersection. Hopefully you got a chance to print out the accompanied PDF that you can practice. And again, in the other video, I talked about the 3 graphing methods to graph straight lines. And again, as a recap, one more time, in order to graph straight lines, we need graph paper. We need to label those axes. We need an appropriate scale. And definitely, we're going to be using straight lines. As a recap, table of values method requires to do some algebra. It is lengthy. It takes a while, but it's pretty straightforward. A lot of you understand. Choose some values for x and find the outputs or the y values. The second method, the x and y intercept method. It's kind of like the table of valued methods, but of course we let the x and y be 0 and solve for the other known unknowns. That's why we get 2 points. Again, some very straightforward algebra methods. But the third and final method, as a repeat, the y equals mx plus b method just simply means you have to count and understand what slope is. The focus more for today is actually looking at the parallel lines and perpendicular lines for this video. To recall, we're talking about more than one line. So with parallel lines, these lines will never meet. A lot of you actually understand that. And so the slope of the first line must equal the slope of the second line. The symbol that we use is 2 vertical lines. Let's give you an example. If we have the slope of the first line, which is 2 over 3, the slope of the second line, because it's going to be a rising line, is also going to be 2 over 3. As a sweet little visual, we get something that looks like that. Perpendicular lines are lines that meet, except you understand that they probably meet at a right angle. And so before we go with the definition, I'm going to show you the symbol that we tend to use. We use an upside down T, and some students actually even put the right angle there. The definition that a lot of you actually know is if we given the first line, first slope of the line, its perpendicular line would be a slope that has a negative reciprocal. As a sketch, really quickly before we get to our example, maybe we have this rising line that's in orange, and the perpendicular line, I'll try to do my best, it's going to look something like this. And so that right line and that orange line is actually reading at right angles. Let's get an example algebraically, though. Let's say the first slope of the line is 1/2. If it's perpendicular, the slope of the new line is going to be -2 over 1, or just -2. Your textbook actually also shows you another way actually to calculate or to figure out. If we multiply the 2 slopes together, they yield a -1. Just be careful with vertical and horizontal lines. Let's move to some algebraic questions, though. Write an equation for each of the following lines. The line that's perpendicular to 3x plus 2y minus 4 equals 0 and passes through the point -1 and 4. So what we probably have to do, first of all, as a strategy, is find the slope of the new line, find the slope of the original line. And the original line is a slope of equation in standard form. So chances are we're going to rewrite this equation in terms of y equals mx plus b. So if we subtract 3x and 4 to both sides, so subtract 3x and add 4, we're not finished yet. We have to solve for y. Y equals -3 over 2 x plus 2. The slope of this line is -3 over 2. And since we're looking at a perpendicular line, the slope of the new line is going to be the negative reciprocal. You flip it and negate it. So we've actually done that part. So it feels like we're having difficulty with this, but I think you guys actually understand what we're going to do next. We're going to use that slope and that point and find the equation of that new line. Now this time, I'm actually going to use the technique that's found in your textbook, where they actually use the y equals mx plus b method. Please note though, you can definitely use the helper formula, but I am actually going to use the y equals mx plus b to actually find the y-intercept, which is the b value. So we're going to plug in y is 4, the slope, which is 2 over 3, and the x-coordinate, -1, plus b. We have to do some rearrangement. And so we're going to add 2/3 to both sides to get b. Unfortunately, we can't just add those two together. You have to get a common denominator. What's the common denominator? Well, it has to be 3. And that numerator, that 4, is going to change to 12. So the y-intercept is 14 over 3. Therefore, the equation in terms of y equals mx plus b is y equals 2/3 x plus 14 over 3. That is the equation of the new line. Let's move on to the second question. The line parallel to x minus 2y plus 3 equals 0 and passes through the point 2, 3. I think you guys actually understand what we just did in the first example, but this take in consideration the slope that's going to be parallel to it. So we have to find the equation, the first equation's slope. And I think a lot of you understand what we're going to do. I added 2y to both sides and divided both sides by 2. The slope of this line is 1 over 2. And since the line is parallel, the slope of the new line is also going to be the same. So it seemed kind of silly to do, but it's just good habits to understand what's happening with these questions. Just like the very previous question that we had in question A, the slope of the line is 1/2. This time, I'm deciding to use the helper formula. And also, I'm going to put the equation into standard form. And I made a mistake. It's okay. At least I caught it, and that's okay. So, I think you know what we're going to do. Distribute the property of those questions. 1/2 x minus 1, right? Because 1/2 times x is 1/2 x. 1/2 times -2 is -1. We have a fraction here, and standard form must be ax plus by plus c equals 0. So a couple ways of doing this. Maybe let's just get rid of the fraction first by multiplying everything by 2. So we get 2y minus 6 equals x minus 2. And then move the left-hand side to the right-hand side, or by subtracting 2y to both sides and adding 6 to both sides. So there you have it, ladies and gentlemen, the equation in standard form that is parallel to x minus 2y plus 3 equals 0, which is this one, x minus 2y plus 4 equals 0. To speed things up for our second part of the question, what we're going to do is graph the following lines and talk about the point of intersection as we end off. First of all, point of intersection really represents the solution where the lines actually intersect. Basically, when lines have different slopes, they'll always meet at least once. Not necessarily will they meet perpendicularly, but they'll at least have a solution. And that's what we're going to be doing. We're going to solve it by graphing. Now, as you can tell, I graphed actually the second line first, that x minus 4y plus 18 equals 0, and hopefully you had a chance to do it yourself. And again, we have labeled axes and everything like that. So I think you understand what we're going to do next. We're going to graph line 1, which is y equals negative 2x. And some of you might have noticed a little slight change in the graphing. So the red line, which is the y equals negative 2x there, I had some difficulty graphing on the tablet. Oh well, I hope you're enjoying my struggles too. It's a lot easier on paper than on the tablet. A lot of you actually can tell the point intersection, or the solution to this, and I'll draw hopefully a big orange dot, is right there. And all you have to do is read those coordinates. The coordinates happen to be negative 2, comma 4. That means this point, negative 2, 4, is the solution for the first line and for the second line. If you need any help or if you need any extra support, please feel free to email me. If you wasn't too sure, you also have your handouts, you have your textbook, and definitely you have the CEMC resources at your disposal. Please look ahead and see our upcoming video, which is going to be on part 3 in the future. Have a nice weekend. Take care.